Okay. We have something to show on agriculture, water treatment, uh, and then something that I have done with the mushrooms, and then an aquarium tank that is under observation. So these are we have mainly three things to show today. So I
Thank
will
you.
share my screen with
If you don't lose
you.
the bandwidth, I know you send your documents to Vince. Rick has them. If you want, we show it from here. Tell us what you send us. We put up that it doesn't put pressure on your bandwidth.
Okay, but it's okay. I think we have a nice bandwidth here, so
Okay,
we
carry
can.
on.
Okay.
Is Dr. Nana from the Space Institute Ghana with you?
Yeah, Dr. Nana is sitting right here with me.
Good
And
morning,
there's
Dr.
a
Ghana.
Good morning,
Good morning.
Mr. Kesh. Good morning. Yeah.
Nice to speak to
uh
you.
okay.
Yeah, nice to hear from you.
Thank
Thank
you.
you.
We hopefully meet soon in Ghana.
Sure.
Okay. Mr. Kesh, Dr. Nana has managed to. Okay. 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 I should go. Okay. There's a publication on the Kesh Foundation in one of the monthly magazines here called Ghana, and Ghanaian scientists should use plasma technology for national development. That was an article that have been written by Dr. Nana, and she is telling the world about our technology, the Cash Foundation technology. I think I need to share my camera so that I can show it or start camera sharing.
Yes, we can see your. Please make sure you don't show us your page that doesn't show the programs.
Okay, okay, yeah,
You
okay,
probably, yeah, you probably don't want to share your screen that way with a video camera. You can share it with the program itself.
It's okay now.
okay.
He wants to show us the magazine.
The magazine.
There you go.
We have a magazine called Ghana, and then there's an article written by Dr. Nana. Uh,
It's too close. Too close.
Too close, okay.
Yeah.
So
Oh, see the power unit and the CO2
power
unit.
unit and then the plasma, and then Ghanaian scientists should use plasma technology for national development. That is an article in um,
As I said, according to the report, most of the first world nations will be behind. They become a third world nation in what you achieve in African nations. Thank you very much. We can see it.
thank you. Thank you.
Let me explain. Benjamin is embedded in the Ghana Spaceship Institute in the final agreement which is getting signed, and the Keshe Foundation and the Spaceship Institute in Ghana's university and Atomic Energy Group will become part of the Development Research Center for Africa. We are financing the whole progress, and is part of what you donate by buying tools from Keshe Foundation. Carry on, show us, please.
Okay. So I hope you can see my screen now.
Yes, as we can see the
Okay.
full page with the
Okay. That's
mushrooms.
fine. With mushroom. So we have to we have on the screen now Catch Foundation Agriculture present water treatment results from experiment. And as you know, we are being hosted inside the Ghana Atomic Energy Commission. So that is what we are doing now. Okay. And okay. So I'll tell you a little bit about the geography of Ghana before we get into what we have to say, because then we can build it from there on. Okay. So this is the geography of Ghana. We have a total land area. The space, including water bodies, is approximately 293,460 kilometers square. And Ghana lies within the geographical coordinates of latitude 8 degrees and longitude 2 degrees west. And Ghana is a small nation, but we are blessed with a lot of mineral resources, which include gold, diamond, bauxite, manganese, silver, salt, limestone, and then hydropower, and also timber, rubber, and then lastly, we recently hit crude oil, so they are mining the crude oil also. And as you can see on the map, on the western side of Ghana, we are banded, we share boundaries with Ivory Coast or Cote d'Ivoire. And then on the northern side, we share boundary with Burkina Faso. And on the eastern side is Togo. And then we share boundary with the sea, that is the Gulf of Guinea or the Atlantic Ocean. So that is how Ghana is strategically or on the map on the African continent. That's where we are positioned. So we have a lot of river bodies in Ghana. As you can see on the map, was taken from a map of the world with all thanks to their thank for using their resources. All the rivers you see, mostly from starting from the Tain and Pra. Some of the spellings are wrong, but PR is not Pru, it's Pra. And then from that side to the Atlantic Ocean, most of the rivers are polluted, are polluted because of mining, gold mining, and people are looking for alluvial gold. Alluvial gold means they dig under the beds of the riverbed, and the way they are going about things is really an eyesore. And if you are in Ghana now, that is the theme here. Everybody is talking about the water pollution, and it's a huge problem here. Most of the places in Ghana don't have proper drinking water because of this menace, and people spend so much to buy water to drink. So I mean, it has come at the right time, and we are trying to do much more to get our acts together, right? Because I sent you an article, I think, some time ago about how the Ghana Water and Sewage Corporation is pumping a lot of millions of dollars into buying of equipment and chemicals for treatment, and they are complaining even that their machinery are running down because of silt, the trapping of silt in the rotating part of the machinery. So it's a big problem here. So I'm going to go on to tell you about the pollution of the water bodies in Ghana. We have two main, sources of water pollution, in Ghana: direct and then indirect pollution of the water body. Direct means, people pouring chemicals directly into these water bodies, and then people dumping the indirect pollution, dumping things on the ground, which eventually get seeped into the water bodies, and that is industrial pollution. And then waste dumping, people dump waste in the water bodies as well, and the illegal mining in the water bodies. This is a huge thing, and we will see as the slides goes on that I mean, it's a big problem here. And the types of pollutants we have include organic and then inorganic, radioactive and acid-based, pollution. So all this, is being thrown into our river bodies, and as if nobody, cares. And we are gradually seeing the effect now. This is from a picture from Joy News that I took. Before, on the before side, you can see that the river is very clear. And then afterwards, after the Galamsey, how the river look now. It's so muddy, and that is River Pra, one of the uh, rivers we treated and sent to the lab for analysis. Dr. Nash is here to explain the uh, um, lab report himself. So when it's time, he will come and then take over. So now you can see now and before. It's very, very, what do you call it, muddy. Okay. And this is how the people go about, polluting our river. This is an artificial way of dredging. They have this man-made or what do you call it, locally made kind of vessel on the river, and they have rods, deep rod, which rake, the bed of the river, and as it rake, the sediment is pumped into what a big vibrating motor, what they call the chamfang or champagne. The local villagers call it, the local people call it champagne, and they, what do you call it, win the gold from this artwork. So that is exactly what dredging means. It's a process of removing sediments and debris from the bottom of water, like lakes, river, dams. And this is very important because most waterways are blocked. So now it is the waterways is not blocked, but they are using the same technology that is used in opening the dams to rake the riverbeds, and in so doing, they add other harmful chemicals like cyanide, mercury, arsenic to the water, to go about the activity. So it end up eventually poisoning, their main aim is to get this, what you see, that is a core of gold, which Mr. Kesh has, shown us how simple it is even to produce it in your own kitchen, if you know what to do. Okay, so that is another stage of how they go about the illegal mining. They pour after collecting or milling, they pour this muddy water, and then it runs through this conveyor belt, and uh, they, what do you call it? Collect the clay, and then also undergoes another process. This is another picture which I got, and you can see them when we travel to the eastern region to collect the Brim River. We saw a lot. I mean, you could even hear on the riverside these people with their boat, their dredging machine on the river, and they don't care. They don't care about anybody, and the people have to buy a lot of what do you call it, water to feed. They cannot even fish from the river and drink from the river. So the effect in the nutshell, this source of pollution give us dangerous ramifications. It we end up getting poisonous drinking water and destruction of food chain. That means when the pollutant gets into the soil, it end up being affected. So let me take fish for instance. The fish end up becoming extinct, and when man cannot feed on it, he also gradually extinct. He become extinct himself, through the process of pollution, and then it have negative impact on the ecology. Most trees at the riverbanks are dying. In those days when you get to bring one fisherman I met at the banks was telling us how bushy the place used to be, and so on. So you can see that it also have impact on the ecology, and then it has drastic or catastrophic weather patterns. So that is another effect. And then, as I said, extinction of aquatic life forms. I asked him, so how do you live? The fisherman at the riverside, he said the fishes are gone, so it's very difficult now. You have to uh, go upstream to get this aquatic life form to feed on. uh, and then we also have seen, or it's in the news, that there are a lot of waterborne diseases in these areas, and cancers. Different types of cancers are common in this area. Borrelii ulcer, and now a lot of diseases are springing up because of the pollution or the contamination in these river bodies. And in the end, we get a high economic cost in water treatment. That means, like I said before, the Waterworks Corporation or the Ghana and Sewage Corporation have to spend a huge sum of money in purchase of machinery and equipment. So that is having a negative impact on the economy also. We can go on to say more and more. In the end, we can see it can also have negative effect on human and animal reproduction cycle because of the mercury you can say I'm not drinking from the water, and you can buy treated water, but you still feed from the land, which uh, uh, um, at the same time, you eat from the polluted soil, so you will have the consequence at the same time, and so on. Okay, I don't want to go political. Okay, so there are other sources apart from this pollution. Also, there are people who deliberately pollute these waters. Like as you can see in the picture, this a man who has slaughtered a goat, and he's washing, the blood and everything in the goat in the river body. So I mean, this can generate what do you call it, biofecal content and E. coli in the river bodies as well, because I will show you another picture whereby this guy is still washing the internal part of the animal inside the river body. So now you see it there, he's washing, as you can see, he's washing the inner part of the animal in the river body. This is man-made pollution. And another picture, this is a journalist covering the whole activity, and you can see him pointing in that direction. They are washing the internal part into this river body. So in the end, we have come to we when I came around, I saw that it was a huge problem. So one day I went to the office of Dr. Nana, and we sat down, and then we said we can do something about it, but I need some quantity of water, this polluted water, to start with. So we got some samples from Brim, we got some samples from River Pra, and then of Fin, and we started, the treatment. So we started using GANs. For those of you who are here today who are new to our technology, GANs is simply a new state of matter, which is gas in atomic nanostate, or GANs for short. And it was introduced by the speaker you heard earlier, my boss, MT Cash. And this new state of matter has different characteristics which give engineers and scientists the ability to do many things. GANs are atomic plasma, and they have both gravitational and magnetic field. If you were here during my lecture here, you will know what I mean by gravitational and magnetic field. And through this, we can do a lot of things, in the improvement of in the treatment of water and other things in the area of agriculture. So as you can see, the first picture is CO2, and then I know many of you know, but for the sake of people who are in, we just show. And this is copper oxide and then CH3. I have them sitting right in front of me here. So it can go around. For those who have not seen it before, you can pass it around, and then we go on those who are here. Okay, so I'm rushing through to finish. Okay, so in preparation to treat this polluted water, we have so far um, done different configurations, in the treatment of these polluted waters. And the one we did on PRA, we used the CO2 and the copper oxide. So in a nutshell, these are things that will be needed for your treatment. If somebody want to replicate it, we need a contaminated water, we need containers, and then we need a measuring flask or a beaker, and then we need the material, the GANs, the CO2 or the copper oxide in a liquid form or in a powder form. And then if you want to go extra, you can use another form of configuration, that is the nano wire, which I'll later show you also. And then you always protect yourself, because you don't know what is inside the water. And we need syringes, the normal medical syringes, to pull our ganses. So these are in effect what you need. Mm. And in this experiment, we divide, in order to check what is happening in the treated and untreated water. We divide it into two groups. So we have the control group and then we have the treatment group. And for those of you who are not chemistry inclined or science inclined, I have defined what control group is. It's used as a baseline of as a baseline measure. That means you put it there to check what is happening in your treatment. The content of the container is identical to all other container, with the exception that it does not receive the treatment or the experimental manipulation that the treatment container undergoes. Okay, so that is it. And then we have the treatment group. The treatment group is a container which undergoes the manipulation or the treatment process. So that is the treatment group and then the control group. So these are initially the samples that we had initially, and from River Pra and then River Offin. It's not the Germans. If a German is there, it's not Offin. It's Offin. Okay. And then
Let me
this
explain what you know the German. Just wait. Let give me a rest
off.
to
Okay.
catch up.
Often in but in German, often is E. It's not I. Often is to open. Uh,
Okay.
okay.
Okay. Let
So
me explain that people know. They know you as Benjamin only.
okay.
Let me explain. We should have done that at the beginning. That's why he goes back to German language.
Mm.
Benjamin
Mm.
is BSc graduate from Ghana
No,
University.
no,
Is it like
MSc.
MSc you received from? Can you explain to us your background?
I studied in Germany initially at the University of Applied Sciences there, and then I moved there to Germany, Austria, to do my master's in information technology management at the University of Applied Sciences, Wiener Neustadt. That is where I got my master's from. And then initially, I was trying to get myself into IEA to work with the IEA because of my interest in atomic physics or nuclear physics. So I applied there, and I was one of the two candidates selected. But politics stepped in, so I have to wait for about 8 months, and there was no reply. Finally, the reply came, and then Mr. Kesh also came and said, I want to work for me. So I just picked the opportunity to, come to Ghana and then work for Kesh Foundation. So that is in a nutshell a small background
But
of
you
Benjamin.
are originally got your degree from Ghana.
Yeah, originally a degree from Ghana before I came to Germany, and then from Germany I went to uh,
Austria.
Austria. Okay,
Yeah,
so
so
that
people
is
know you're a highly qualified person to do this job, and that's
okay.
why
Okay.
you present the technology so beautifully. He's born and bred in Ghana, and he's gone back home to serve his nation. This is what we do in Keshe Foundation. We see now the next presentation the same with Kenya, and we're seeing with Alex with Nigeria, and we have a gentleman which goes back, highly educated, back to Kenya in the coming time. Thank you very much. Carry on.
Okay. Okay. So in the treatment steps, we both the control treatment container were rinsed initially with about 25 ml of the polluted water to set them, because a scientist will question you, did you set them at the same time? So we set the both containers which we are going to use to for the treatment. We cleanse it with about 25 ml of the polluted water to set it off. Okay, and so after we rinse it, meaning we pour the water away after shaking it or agitating the bottles, we pour them away. Okay, and then we measured equal amount of the polluted water in both containers. Okay, and then the control container was closed, and then we put labels on, we labeled it, the name of the river, the date, and then the time of the experiment, so that we can actually do statistics and graphing on it when the times come to show the impact and what we found in the water and so on. So uh, after that we introduce 7 mil of gans into the treatment container. Okay, so that is what we did, and then we left it off. That is immediately after the application of the gans, in the so A is the treatment, as you can see on the screen. A is the treatment container, and B is the control. And we bought these special glasses because we want to identify them it's color coded. So one is green and then the other is pink, orange color, so that we can easily also label them. Or it's good for write up also when you are writing something also on it. And then after this is the treatment. After 24 hours, we can see that the water have sedimented, and the upper part is more clearer than the control. The control still remain almost the same, although there are sediments. It's still, the turbidity. Turbidity is, um, to explain to the layman, the clarity of the water, the suspended particles in the water. If you shine a light through it, how it can get to the other side. So you can see that the water is more clearer than the one that we are under treatment. Okay, so that is it. And then this is the CO2 treatment. Let's see the copper oxide. The copper oxide look more clearer, and each and every time it gave me a clearer, what do you call it, turbidity. And then the springs as well, but I don't have the springs to show today. But on the table, or what we may show live, how the whole thing is done, is also, we have also some springs, the nanowires uh, treatment also to show, if time permits us. Okay, and so I leave the report now for Dr. Nash to come and then take over from here.
Okay, I was just about to ask.
Stay online. Stay online. Don't move. Let them come back. Stay online. This is the report we seen a couple of days ago sent to us. We have a copy of it here in case anything happens. But Dr. Ghana of the Space Institute with the National Nuclear Research Institute of Ghana.
Sorry, you can go ahead there, Mr. Cash. You just might need to unmute. I knew he was going to drop out there.
Yeah. So as we see, we wait for them to come back, or when they come back, we bring them back on. We're expecting problems in communication with Ghana. So as you've seen, the test is done under very scientific condition in the laboratories of Atomic Energy Authority of the Ghana, and we see the same kind of collaboration and cooperation with different governments now, with different part of the Keshe Foundations worldwide. This is what we emphasize on. We invest heavily in Africa.
It looks like he's back as well. Benjamin, can you try unmuting, please?
Is he there?
Yeah, I'm back, please.
Okay, carry on. Show us. You've just seen the report.
Yeah,
Can you share your screen again, please, Benjamin? Or if you're getting low bandwidth, maybe we should move to Rick sharing the PDF.
Can you see now? Yeah. Yeah, so with the full water quality treatment, we did
Who's speaking, please? I think the speaker has changed.
Nash.
Dr. Nash.
Nash. Yes,
Atomic
please.
Energy Authority. Hello, Dr. Nash.
Can we try resharing the screen?
Yeah, so for the water quality test, we did physical.
We can't see the
We
screen.
need a screen share on the document, please.
Yeah, can you just reshare it, please?
Hello. Hello.
Rick, maybe this is a good time to move over to you sharing the PDF. I think that's what he was showing.
I think yes, but they have set up a presentation PowerPoint. We have to follow theirs. We don't have the PowerPoint presentation, do we?
I think I sent it to you, Rick.
Benjamin, if you are there, you don't need to share screen. You can go on the voice only.
Okay, voice.
We have your documents. We can show it that it doesn't put pressure on the bandwidth.
Okay. Yeah, so
Yes, we got
so
your
back.
report. Dr. Nash, you can speak here, please. We have the results on the screen.
Yeah, yeah. So with the water sample analysis, we did the physical parameters, nutrients, and then we did trace metals. For the physical parameters, we did pH, temperature, conductivity, total dissolved solids, total suspended solids, alkalinity, turbidity, salinity, apparent color, and true color. We compared it with WHO and then Ghana Standard Authority guidelines for drinking water. For example, the Ofin River treated the pH was 7.27. Then the Ofin control, so 7.62. Then with the PRA treated, it's 7.73. And then the control, 7.55. So when we compared it with the guideline values for drinking water, WHO and Ghana Standard Authority, we have it's between 6.5 to 8.5. And then for Ghana Standard Authority, it's 6.0 to 8.5. So we compared the values that we got from the analysis with that of WHO and then Ghana Standard Authority. The conductivity, which is in microsiemens per centimeter, for the Ofin treated, we got 357.5, whilst the control, we got 268.5. Then for the PRA treated, we got 2,325. And then the control is 178.2. The range, according to WHO, is 500 to 700 microsiemens per centimeter. Then it follows suit with the total dissolved solids, also in milligrams per liter. The Ofin treated, it's 179.3, whilst the control is 134.65. For PRA treated, it's 1,164.45. Then the control is 88.9. The range, according to WHO and Ghana Standard Authority, is 1,000. Then the total suspended solids, the Ofin treated is 210, the control is 35, whilst the PRA treated is 230, the control is 5, and then the guideline is 5. For alkalinity, the Ofin treated is 45, the control is 75, and then the PRA is 65 for the treated, and the control is 105. The range is 200 according to WHO and Ghana Standard Authority. The turbidity, also in formazine attenuation unit, it's 200 for the Ofin treated, then 32 for Ofin control. Then the PRA treated is 226, the control is 4. The range, according to WHO and Ghana Standard Authority, is 5. Then we come to salinity, which is in parts per trillion. Ofin is 0.2, the control is 0.1. The PRA treated is 1.1, then the control is 0.1. We do not have the WHO and Ghana Standard Authorities levels at the moment. Then the apparent color, which is also measured in platinum cobalt unit, is the apparent color is the color of the water as it was presented to the lab. Then the true color is after it has been filtered through 0.45 millimeters Wattman filter paper. So the apparent color is 220 for the offin treated, and then the offin control is 20. For PRA is 50, and then the control is 1. The guideline values is 25, and then to 100. So when we come to the true color which has been filtered, from 220 as apparent, the true color came down to 15. And then the offin control also dropped to 3. Then the prior treated from 50, it dropped to 5, whilst the control from 1 dropped to 0. Then for the nutrient analysis, we did fluoride, chloride, sodium, potassium, total hardness, nitrate, phosphate, and then sulfate. They are all in the milligram per liter unit. The fluoride for the offin treated is 0.015. The control is 0.011, whilst the PRA is 0.0051. Sorry. And then the control is 0.013. The guideline values is 1.5 according to WHO, and then Ghana Standard Authority is 1.0 to 1.5. Then for chloride, the offin treated we had 9.99, while the control is 48.98. Then the prior treated we had 596.81, while the control is 228.99. The guideline values is from 250 to 1000. And the sodium for the offin treated is 13.2. The control is 17.9. The prior treated is 85.7, whilst the control is 16.8. The guideline values is 200. Then potassium, the offin treated is 1.5. The control is 2.5. The prior treated is 6.5, whilst the prior control is 1.0. The WHO guideline is 30. Then the total hardness for offin treated is 52. Offin control is 65. Then the prior treated is 48, whilst the prior control is 53. The WHO and Ghana Standard Authority guideline level is 500. Then we come to nitrates as N. Also in milligram per liter, it's 0 for offin treated is 0.406, while offin control is 0.318. The prior treated is 0.002, whilst the control is 2.066. The levels is between 10 and 45. Then phosphate, it's 0.034 for offin treated. Then offin control is 0.683. The prior treated is 0.012. The control for prior is 0.218. We do not have the both WHO and Ghana Standard Authority levels as at now. Then for sulfates, we have 2.5101 for offin treated. Then the offin control is 2.0089. The prior treated is 0.014, whilst the control is 1.021. The guideline values is from 250 to 500. Then we did trace metals. For the trace metal, we did total iron, total manganese, total copper, and total zinc using the atomic absorption spectral meter, that is the AAS. They are also in milligram per liter. For offering treated, we had for iron 0.217 for the treated, and then the offering control is 0.420. The pra treated is 0.203, whilst the pra control is 0.501. The guideline value is 0.3. Then manganese, it's 0.010 for offering treated, then 0.031 for the control, whilst pra treated is 0.027 with its control 0.040. The guideline value is 0.5. Copper. Copper, it's less than 0.003. That is below the detection limit of copper using the AAS for treated offering, both the treated offering and then offering control. For prior treated, it's also below the detection limit, which is 0.003. For both treated and control, the WHO value is 1.0. Then we come to total zinc. Zinc offering treated is 0.039, then its control is 0.077. Then prior treated is 0.031, then prior control is 0.072. The guideline value is 3. So these are the analytical reports for the samples received both from the Ofin River and Pra River.
Thank you
Hello.
very much, Dr. Nash.
So, in effect, these are this is we have not really completed with our findings. It's an ongoing thing, and we still need to refine our way because um, there are other things to do, like to beat down the salinity level, because the salinity level has also influenced the total suspended liquid and then total dissolved solid. So we are trying to do more to refine the way to beat down these levels. But according to Nash, Dr. Nash in the lab, he told me this can be taken or it can be used because most of the wells that are dug even does not pass even this what do you call it this test. So
What does it,
um,
can you explain to us, or let Dr. Nash explain to us,
okay.
what has it changed? We need, it's all data. They are experts. Can we understand what has
Okay.
changed in the water? What is the condition of the water? Hello?
Yeah. Hello.
Dr.
Yeah.
Nash, can you enlighten us with your knowledge? What is added? What is changed? Is the water has changed for consumption? Is the water what need to be done? And then we will take it to the next step.
Yeah. In summary, with the water, the treated, there has been a improvement in the treatment done on the uh, untreated water, which is the control, except the salinity level, which is especially for the prior treated water, which is 1.1, and that's on the higher side, according to the previous analysis that we've done with
Okay, can
different
I ask you two
water.
questions?
Yeah.
Because the gans comes through the salt water, created through the use of salt water. Was
Yeah.
the water washed thoroughly? The gans was washed thoroughly before you added to it?
No, Mr. Kesh, the guns was not totally, washed. What I have also discovered.
Can you, excuse me, um, Benjamin, can you explain to us what was the condition of the water gans you used for that test experiment?
Okay, it was taken directly from uh, um, the the setup, the gun setup. So
Did you wash it with the distilled water? Was it washed?
it was not washed because at that
Okay.
time I didn't have distilled water, and I didn't also want to use the tap water because the tap water have traces of minerals in it, and I don't want to influence
Okay.
the outcome.
So, Dr. Nash, the salinity can be explained because we use salt water to produce the GANS material. Putting
Yes.
that aside, what is this water drinkable? Is this water usable? Or what does it need to be done for it to become usable?
Yeah, it can be used except the color which needs to be filtered. Because when you look at the apparent color, it's 220, which is far above the recommended guideline value. So if the water can be filtered, then it can. Even with the offering treated, after the filtration, it's still 15, which is more than the guideline values, which is 5. So it means it needs to go through further filtration before it can, at least if it is below
Can
5.
I
Yeah.
can I ask you a question? Because I had this the same with another test trial. Did you
Uh-huh.
take the water from the top separating the residual, or did you test it with the residual in the container?
Yeah, in the container we took from the top. That is clear. That's the with the treated sample. We took from the top.
So
But
there
with
were no
the
residual in it.
no, they are not.
Did you
Can
Can you
let
you
it?
explain to us?
can you explain to us why then we see a clear bottle on the left, but what do you call it? But the river untreated is still so muddy. What's the why? Why do we see it? But in the apparent color and the true color, we don't see it in the test result.
Yeah, with the you realize that the apparent color, the values are quite high, but with the true color, which after the filtration, the value drops, especially for the Offin River, which is for the apparent is 220, then it dropped to 15, which means there's still room for improvement.
Can I ask you another question? Why do we see this is something I would like to know because it helps the other authorities who use this or they're going to consider to use it. Why do we see a higher apparent color after treatment, but we see a clarity in the water after the treatment?
The clarity of color after the treatment.
Yeah,
Yes,
when
which
you look at the two bottles,
yeah,
one which is not treated,
yeah,
it's a clear water we see, but on the right side, when it's not treated, it's still yellowish, orangish color. And but when you do your test, the result shows
yeah.
totally different. This is what I wanted to know. How come the water is clear in the bottle after treatment, and but when you do the test analysis, the color looks to be more muddier or not clear as it shows in the container? Because the visual observation does not comply with the data on the paper. Visually, we see, because I look at your turbidity as well, it's 232, 226 and 4. But when we look at the bottles in front of us in the test cases, the water is very clear. And the other water from the river untreated is not very clear. But when you show us the data, the two data does not match with the visual observation, where it says apparent color is 220. You have to filter it to
Yeah,
get it better. Where
yeah.
in a para control was 1, now is 0, and then the other one is 50 becomes 5. Is
What does it actually mean, apparent color and true color?
Maybe it means something different.
Yeah, the apparent color is the color of the water as presented to the lab. That is before filtration. And then the true color is after the filtration.
That's right. Yes, I understand that, but what doesn't come to visual observation, the color of the water is very clear. We see it in the bottle,
Yeah, in the green
in
lid bottle.
in the green one. But when you
Yeah.
test it, it doesn't confirm that. Why?
The, that
Is,
was
is it the possibility that the figures have been misplaced?
uh, the the treated. Yes, we have to do it. Look at the treated should rather be 20, and then the control is okay.
The figures
Yes.
with the visual observation don't add up. I
Yeah.
think in this process, figures are typed in the wrong column, if I'm
Yeah.
correct, or you have
Yeah.
to enlighten
Yes.
us.
Yeah. So we will have to do further test on it. It looks like the topographical something. It should be 220. It should be 20, and then the control should be 220.
And then 50 and 1
Yeah.
should be in the same position.
Yes. Yes.
Yeah,
It should be.
so it shows a
Yes.
huge difference.
It should
And
difference. Yes.
then we see with the tunability the same, where it was 200, now it's 32, where it was 226, now it's 4. This brings a
Yes.
lot of things in line. Is it possible that you could check the data and come back to us in next week or two,
Yeah. Sure.
some further
Sure.
tests, and you have the data correctly? What if you put those in line correctly? Would
Yeah.
this show us that would you drink this water after treated?
Yeah. After treated, it is.
It's
After treated,
drinkable.
it can be drink. Yeah. It's drinkable. It's
So,
drinkable.
Okay.
uh,
Mr. Cash, I have a fundamental question, and I mean, it's not to me to judge the testing procedures or the results or whatever, but I have the question to the guideline values for drinking water, since the GANA values follow obviously the usual WHO values. I'm not about to judge the conduct, as we know from your own experiences, Mr. Cash, about the activity.
no, we're not going that way,
No, no,
please.
no, no, no. But I have a fundamental question about the values, because I know from the internal documents for the tobacco industry,
Yeah.
when it comes to ISO norms or ISO values, usually 80% of the people who make the
And
parameters and the norms are from the tobacco industry. So who are these people who make the values?
No, we don't question. We are not. I know you're a doctor in that way, K1. Yeah, I know you understand this, but we don't question the authorities. We question our own technique and technology. We are setting new standards.
Okay, but it's drinking
So
water. So
it's a
what?
drinking. This is all it matters. We are not here to question WHO or anybody else. We are here to look at the data we have, and does the technology works for water treatment? This is very important to us. And what I see, we have experts. We have Dr. Nash, we have Dr. Nana, we have a scientific based man, Benjamin, all highly qualified people within the National Nuclear Research Institute of Ghana. What we want to know, putting those entries correctly and checking the data, would you come back to us and we look at the correct entry? It could be the secretary doing the thing because he was in a rush to be done.
Yeah.
And then what it looks to me, everything seems to be in the right order, and where, unless we see a changes like this, you can pick up because visualization is there. It's a beautiful job what you've done there in Ghana. I thank you fantastically for what you achieved. But what can we do with these sediments? What's your opinion, Dr. Nash or Dr. Nana? Can we use these sediments, what we have collected, because they haven't disappeared? You're testing the upper level water, as I asked you, said you done.
Yeah.
You have a residual. Now we have these
Yes.
minerals in this residual.
Yeah.
Can
Then what we
we?
intend.
Yes, can you
Yeah.
carry on?
What we intend doing is we will analyze the sediment separately. In
Mhm.
fact, we will analyze for trace elements and then heavy metals. That's the toxic ones like mercury, lead, nickel. Then the essential ones like iron, manganese, copper, and zinc, solely on the sediments. And then by next week, as we meet again, we will also have a look at the findings from analyzing the sediments.
Yeah,
From
I
then,
think.
we can know what it will be used for.
Can I ask a question? There are ways to extract these minerals which are collected in the sediment
Yeah.
to utilize for national, what they call assets.
Yeah.
We can show you and the Atomic Energy Authority how to separate like iron or copper or zinc or even gold. If you can measure the gold content in these sediments, that
Yeah.
it can be added to the national reserve, because this, when you do it in the larger scale, we're not talking about grams, we're talking about kilos and tons over every year of operation. So
Okay.
the system is pays for itself. This is what we did with Fukushima with the Japanese government with TEPCO. We show them
Okay.
how to convert the the what I call the tritium into gold within
Contamination.
their tanks. Then what
Mm.
our purpose is not only cleaning, but making what is cleaned off not to become a problem for another thing. We solve all the problem in one go. So the way what I see, maybe it's a good process to be done for Atomic Energy Authority, is once you cleaned up the sediment, if you can
Yeah.
separate the residue of the mineral, which all can be sold. Iron is a quality value merchant, magnesium the same, copper and zinc the same, then we
Yeah.
can recycle the CO2 or a copper oxide back into the process. You don't need to keep on making it. So
Okay.
these are the things which in overall run, which have to see that it makes the system self-sufficient. In what you clean, you clear a lot of materials from the water of the rivers,
Mhm.
which becomes a national
Yeah.
asset. This
Okay.
is what I would like to see, if we can look in that direction with the head of Atomic Energy Authority in your country, that then this
Okay.
gives the money for the institute to be able to develop their own technologies. You don't need to wait for the handouts from other governments. If
Yeah.
you can go in a little bit, spend another week or two on this and
Okay.
analyze all the materials. We guide you. I can
Mhm.
give you all my time. I can fly to Ghana, stay with you a few weeks till we get this done. But at the
Okay.
end, you are a rich nation. And Atomic Energy Authority or the Nuclear Research Institute will clear the rivers and makes an income for the institute to have money to invest in the research and new scientists. This is what the purpose is. Okay, we got a clean water,
Awesome.
we can consume
That's
it.
great.
Pardon?
Mm. Okay. I'm saying that's a great idea.
Yes, this is what how I went with TEPCO. And when TEPCO made a lot of money out of it, they started draining gold. They kicked our guys out because they thought they're independent. But in other words, you have a, if these people are searching for gold and doing the dredging to do the gold, there must be huge amount of gold floating in this water. If you can test for the water content, if you
Mm.
can test for clarity and gold and silver content in your test for next week or the week after, and then
Okay.
we go through the process of separation. It's very easy to separate most of these from the gans, and you refeed back the gans
Yeah.
into the system. But the beauty of it is the water is clean enough to drink, according to your opinion.
Okay.
Am I
Okay.
correct?
Yeah. You please. You are. You are. That's correct.
Okay, that's I would like to thank you for your collaboration. And as we said, we are prepared to invest in Ghana and Keshe Foundation in conjunction with the Space Institute of Ghana, as we are becoming
Yeah.
part of the embedded in your organization. Keshe Foundation investment is open to Africa in every shape or form, and we have a trusted bond with you. And
Yeah.
I will see a huge collaboration. This is a fantastic presentation, and I
Mhm.
thank both you and Dr. Ghana and Benjamin and head of the Nuclear Research Institute of Ghana, Atomic Energy Commission.
Mr. Kesh, we
Okay.
have still more to show.
Yeah, too much to show.
Pardon?
Thank
We have
Thank
still
you very
more
much,
to
Dr.
show, sir.
Nash.
We have still more to show.
Okay,
And
carry on. Carry on.
we need equipment also here because most of the tests, takes a lot of time, and Dr. Nash can tell you I give him a lot of hell of, so we need a lot of equipment here, and to test some of the next stage of what I'm going to show is the fish, the aquarium stuff.
Carry
Um,
on.
okay.
Is Rick, you got to let him to share his screen. You have to take the PDF down, please. You are controlling. Okay, share your screen, please, for us.
Can you see?
You haven't come up yet. We are waiting. It says you're sharing a screen. Hasn't started sharing a screen. You're waiting for you to come up.
I've shared it, so.
It says Benjamin Mensa has started sharing a screen, but we don't see your beautiful face
You
yet.
can try to stop it and do it again.
Stop it
Share.
or do it again.
Okay, so share. I'm sharing again. Is it true?
No, it has not come in yet. Uh, it says you want to share. Yeah, we see a picture of a man and a woman. Is somebody else sharing somewhere in the background?
No, it's just it looks like it's a bandwidth issue. Just try choosing something else first, Benjamin, and then try going back to that.
Vince, that's what we yeah, it comes up. Vince, that's why I say we need our own satellite system in Africa. We need our own connections.
Yeah, I've been working with Benjamin and
Let me,
Alex.
while Benjamin is online, while Benjamin is trying to get sorted this out, let me explain to you something which is very important. We would like to thank the American organization who has allowed us to place um, Benjamin within the structure of the Ghana Space Institute. This is part of the work we do with secret intelligence services and the others. And through their support, especially people we do not mention in the front, within the structure of the communication of the American government and industry, who have supported us to bring the position of Benjamin into Ghana. We collaborate again with them. They are part of the Keshe Foundation International Organization. And we thank them. They know who they are, not to disclose their names, for the facilitating for Benjamin to return as part of the Keshe Foundation into Ghana. We thank the organization like within the structure of CIA and the rest who we collaborate with very closely. We know who they are and they facilitate these
Can
things
you
for us.
see?
Thank you
Please,
very
can you
much.
see?
We can
Can you
see
see
you.
our screen?
Yes, we can. So
Okay.
this is by having Benjamin there is a collaboration of governments and people within being in the government or are part of it, and we use the governmental connection to facilitate this. And I thank our American support for this move. Go ahead, Benjamin. We see both fishes.
Okay, so we have two tanks here. The the green tank, and then the do you see it? The green tank and then the yellow tank. Actually, what I'm doing here is to uh, do a lot of tests on the water, and also the from like on also the what we get from the aquarium. So I have taken already samples to Dr. Nash's lab to do some tests on the water. Okay, if you can see, as you can see clearly, there are differences in the turbidity. One is more clearer, and then the other, which is not treated, is a little bit darker. That is the green tank. I don't
What
treat
have you
them.
put in them?
We have two fishes in each tank with other small ones also. So what we have in here is I have a filtering stage, and I have a submersible pump, and I have an aerator. That means they can, what do you call it? It uh, takes air from outside and then convert it to the oxygen and carbon dioxide process, so that the fish can live on on them. Okay, and I have in the tank also a natural and an artificial weed. The natural weed is also to do the same thing that the pumps are doing in case the power is taken off. That is a fail-in safe mechanism I put in the tanks, so that if the power goes off for a long time, like 2 days or 3 days, the fish can still, use the natural system to, take in air and then prepare food for themselves. So what you see here, if the camera can come a little bit further, which is not, can you? Mhm. Uh, okay, if you can see from the filtering chamber that the water which is not treated with the gans is more dirty, and I've taken a sample to Dr. Nash's lab, and it's the same thing. The water is more dirtier, okay, with the tank, untreated tank. But the one that is treated or fed with the CO2 has less pollution, or has less, what do you call it, sediment collection. And so what we are doing is we are also, I've given Dr. Nash some parameters to test, like the pH level, the ammonia level, the nitrate and the nitrate, copper, chlorine, and general hardness, and carbonate levels, and then phosphate, dissolved oxygen, iron, salinity, and then calcium. Because we don't have so much, what do you call it, equipment here, some of the tests, like I need electronic scale here, and I've told the guy who brought the fishes to me to bring me a pH meter, and he has not still surfaced, but I'm still waiting for him to bring it. There are some tests I can do them myself at home, and to measure also the fish size, we need a laser tool, a kind of laser tool, to actually measure the length of the fish, and then the weight. That is um, what we are going to use the electronic scales to measure. So, in effect, what I'm going to do is to fetch the fish in a container, and then first of all I'll fetch some water from the tank, and then zero it with the water on the scale. I will put it to zero. That is, I'll make it weightless, and then put the fish into the water, and then measure the weight of the fish. Okay,
Can
so
I ask you a question?
yes,
What are
sir.
you feeding? What have you used for the clear tank?
Okay, the clear pack I have used, the clear pack I'm using CO2 in combination with the food of the fish, but the
Please,
other one I
please,
feed.
please do not use copper oxide as a mixture.
No, no copper oxide,
Yeah. Okay.
CO2, CO2,
CO2.
because copper oxide will finish them in no time. Okay, so I'm using this. I'm using this also to feed them, but the one which is not treated with the gans, the CO2 gans, does not. I give them less of this food, more of the food, and then the ones that are fed with the CO2 get just a little bit of a fraction, just a fraction of this feed. So, but when you look at the sizes, they are growing bigger and more aggressive, or more happier than, and they can sink deeper than the one that are not, the water that is not treated.
What do you mean?
Because
You're
for
feeding the treated one more or less?
the treated one, I feed them less.
Okay.
I feed them less. But the ones that are not treated, I feed them more, but still, and in terms of aggression and size, the treated ones are growing bigger. As the people who I constructed, Gilbert is here. Gilbert has seen them from the day we started, and they are growing well. So that is it. We have some more time to see how they fare. And also we have mushroom here also to show there are some mushroom experiments that
Can you show us this famous mushroom? I've seen pictures, but I don't know what it means. You keep on sending me reports and pictures, but I don't know what is a mushroom. Tell us about the mushroom, please.
Okay. uh, can you see?
It says, why do you feed them less?
Why do I feed them less? Because we are feeding them with CO2, and CO2 even should be enough for them to live on. Because
Yeah, I think
uh,
if you feed them equal, then you see the effect of CO2 because now you're interfering with the food. I think
okay,
you bet. I think you gotta feed them exactly the same to be correct, and then you
so
see what the CO2 add to it.
okay,
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 carry on. Is that
okay.
Dr. Nana hand showing everything?
Yeah,
Hello,
yeah.
Dr. Nana. It's nice to meet you again. We met in Rome during the ambassador meeting. Thank you very much for your help and cooperation, Dr. Nana.
Okay, so I have here two boxes, but in each we have the mushroom composite bag. This is a composite
Go a bit
bag.
lower. Yeah.
This is the composite bag, and in the composite bag are the mushroom. How the mushroom is made? It's made out of sawdust and wheat brown, and I bought them. I think how many days ago? It's 2 weeks ago, okay? And we started treating, what do you call it, the mushroom with the gans. The first ones that I received are these ones. Uh, can you see?
Yeah.
Okay. So I actually washed the mushroom, the treated the CO2 gans. I actually took all the salinity from the gans out and then watered the composite bag, the first two with the CO2, and then in no time, about 2 or 3 days, the uh, mushroom started sprouting. So that tells you the power of it. But the guns, and then the other one I left it. The one that are coming up now, it have taken slow time to show up, and it's now coming up. Um,
How
uh,
old are the
that
tests? How long is the test done? That one is just showing, and the other one has grown so much.
you say? Okay,
Yeah.
2 weeks. But what I will do is I'm going to this one the same. I planted them the same time. So what I'm going to do is I'm going to take samples of this mushroom to Dr. Nash's lab, and then we see what is in the one that is watered with the gans, and then the one that is not watered with the gans, and then we see whether nutritionally we have improved upon that or not. And then based on that, we can do furthermore experiments with the growth. Uh, and one
Um.
thing,
Okay. So the
one
one which is grown over the box is grown at the same time, but you just put CO2 in the water.
yeah, yeah, in the water,
Okay.
in the watering, what do you call it, pot, so that
There is a question on the panel asking, how did you put the CO2 with the fish tank? Did you add it or is it there just as a field?
Mame, so I have the guns. Okay, I have uh, the guns in my hand, as you can see,
Mm-hmm.
and then a string. So what I do is I draw 1 mil of the guns and then drop it in the tank.
I think you can just put the container in the center without doing anything, and the fish will get the same. You don't need to add the gans into the water because you are dealing. You still work on the matter state thinking. You're adding it because you think it's going to take. Gas works on a plasma condition. So what I think
Okay.
you better do, um, put that CO2 container just in the water. The field of the plasma of the gas will go out, and I think it'll have the same effect as you're putting in there. This way, you can feed the fish for hundreds of years. That way, you're going to run out, and you have to make more.
Yeah. Okay. That is true. It was full, and I have been, filling
Putting
it
it.
all the time.
Yeah, just
And
put the container. You don't need. This is what you got to realize. Even the process of the cleaning of the water. Try to put the CO2 in a container and let the water
mm-hmm.
inside the water. That you don't need to get you don't need to add the gans into the water, and see if you get the same results. I'm sure you get the same results of cleaning and everything else, because we have to
Okay.
change the mindset from the matter to interact than the interacting the fields. So if you put your CO2 bottle in there, you can leave the fishes. They go to it and you see they start eating from it. They nibble at it and the water continues to get fed, because this way you have to keep on adding and adding, and that way they just take the fields. Most probably they stop eating. You got to observe how much of the food you give is going to stay at the bottom, because when the fish is not hungry, it won't eat. And if you clean up the bottom that there is no residual, then you can compare if the food still stays at the bottom, or would it rot, or would it just stay there as fresh, because the CO2 will do the job for it to clean it. So I think you better stop feeding them. Just put a container in and
Okay.
see if
That's
it
what.
doesn't change, or put another tank and try this. Carry on breathing, because now you get the CO2 in the process of the
Mm.
animal, where that way you get the energy but not the CO2 as part of its digestion system. You understand? And this is where the difference should come.
Okay. So I'll do that. I even was thinking of that the other time because I bought some copper plates. I want to do the, what do you call it? Put the plates inside and the zinc inside and see for it to start producing
Do
the
not
gans.
put any copper in any of them. You will kill the fish.
The nano coated copper. The
No,
nano.
nothing, nothing,
Okay.
nothing.
Okay.
You cannot introduce copper, especially in the white meat.
Okay.
If you introduce the copper into this environment, I'm
It's
sure,
too
because I
it's too
tell you from
physical.
experience, your animal
Physical.
will die very quickly, because
Mm-hmm.
the energy is too much. They cannot absorb it.
Mm-hmm.
The growth of the body in a white fish is different than the red fish and red meat, and then it can cause in the growth, and the expansion is not what it's looking for. You can't reach it. Do not use, never, especially with water animals. Any, you can do it maybe with tuna only, but all the small fishes with the white, what we see, what we call the water fish, do not please feed any with CO2. We have seen them. The energy impact is too much, and the animal dies.
Mhm. Okay. Mr. Cash, it seems
Yeah.
they need the conference room for another.
Can I
Uh,
ask you a simple, quick question? Is the doctor
mm.
with the stroke arm with you, or has he left?
He's here.
Can we see his arm? Is he driving?
No, he told me he's not driving now. That's what I said. I'll confirm. He told me he's not
But is
driving.
there any difference in his hand, or can he tell us what he's seen?
He doesn't want to.
Okay, let him speak. It doesn't matter. Do you see any? Good morning, doctor.
Hi, good morning.
Hi. Do you see any changes in what you're doing there in regarding your stroke with your arm, please? Because I know you're doing
Yeah,
something in the
a
background.
little bit. A
How
little bit of.
much?
Um,
Can you pick the microphone a bit higher, please?
well, I think maybe this is I can't tell, but it helped me. Yeah.
Uh-huh. Okay, we keep an eye on you to see how far we can go, and I'll try to explain to Benjamin how to help you directly, because you can
Okay.
reverse most of it. Thank you very much, doctor.
Thank you.
Thank you for your time. Okay, I know you got the hand over the room. I would like